Hello everyone, welcome to this week tutorial. So today's tutorial topic is crank slider. We'll try to analyze position, velocity and acceleration for a crank slider. So in this video we'll introduce the length of the crank slider, how we denote the length and angles. Then we'll introduce the equations, vector equations of position analysis, vector equations for velocity analysis, and also for acceleration analysis. Alright, so this is a typical crank slider where O2 is a fixed pin joint, link 2 is an input link, either it could link 2 is an input link, B is a slider. Actually, this is a slider, so the center of the slider to the pin joint of link 2 and 3 is the coupler link or link 3, and then the right angle, just right angle from the center of the slider to the line which is parallel or connected to the fixed pin joint is called offset. It is 90 degree with the x-axis, positive x-axis counterclockwise, or you can consider this is a theta 4, which is 90 degrees. So you can understand from this diagram that when the slider slides in left or right directions, the value of d also changes. So when we solve the problem for crank slider, or when we analyze position, velocity or acceleration for crank slider, we are also looking for slider position, slider velocity and slider acceleration, because that d or the position of this d depends on the slider velocity or slider acceleration or slider movement. Okay, so this is the general denotation for input link. So link 2 as like 4-bar linkage, we consider link 2 as input link, as a length. The length of input link is A. Coupler link, which is link 3, we consider the length of this link is B. Offset, which is just perpendicular from the center of the slider to the axis of the pin joint, is considered as C, and the slider position is a distance from the fixed pin joint to the center of the slider, which is present as which represent as D. Okay, so if we look at this zip file and try to understand which one is input, so we can understand that definitely this small link is input link. So this is link 2, the length is A. This is coupler, which connects the input link and the slider, and you can see that the slider slides. So we consider this length from here to here. The slider actually goes from left to right, so that's why we consider both arrows, and this is the slider position D. And from the pin joint to the center of the slider length, vertical length, we consider as offset C. Okay, so for position analysis, two equations will be given to you, one for theta 3, the other is for D. So for theta 3, this is the theta 3, and D is once again from fixed pin joint to the center of the slider. Before we identify the theta 3 and D, let's consider which configuration do we need to identify. So I found limited literature on pin configuration, cross configuration for crank slider. So what I found from Norton's Norton's textbook and Norton software that when the slider is on the x-axis or right side of the y-axis or in towards the positive x-axis direction, that time we consider as open configuration. When the slider is on opposite direction, that means when it is in towards negative x-axis or left side of the y-axis, that configuration we consider as cross configuration. So why open and cross configuration is important? Because when for crank slider equations, you will not be given any separate equations for both configurations. So from the same equation, you need to, depending on the which configuration you're identifying, you have your answer would be different. So for cross configuration, the value, so for cross configuration, theta 3 we get from directly from the equations, and for open configuration we need to add or subtract the calculated angle from 180 degree or with 180 degree to make it positive x-axis and counterclockwise at the root of the vector. Once we identify theta 3, then depending on the value we get, our d will be calculated. So we can see from open configuration, usually the d value is positive. For cross configuration, d's values would be negative. So this negative means the direction of the d vector would be negative. To identify the angular velocity of coupler, for crank slider equation is given to you. You just put the value of respective length and angle, and you'll find angular velocity. For d prime, which represent the slider velocity, now you can understand that slider is a pure translational motion movement. So the value we get, it can be written as VB, or the velocity of pin joint B, or the velocity of the slider B. So we can write VB equal d prime and whatever we get. So the VB magnitude would be the magnitude absolute value of d prime, and 0 if d prime's value is positive. If d prime's value is negative, the angle would be 180 degree. Why is that? Once again, if you just look at this diagram, so let's consider the slider is moving towards the right directions. So the angle, according to the definition, the angle would be with positive x-axis counterclockwise. Now the vector movement of slider and the positive x-axis are both in the same direction, so the angle would be 0. Now let's consider the slider is moving in opposite direction, which is towards the left. Now in this case, the angle, once again, by definition, we measure angle at the root of the vector with positive x-axis counterclockwise. So when the slider moves to the left, we get angle 180 degree, and that's why when you calculate this value, if we get positive value, it should be 0 degree. If we get negative value, it should be 180. Please look at the 4-bar linkage linear velocities derivation. It's exactly same as 4-bar linkage. Acceleration, once again, both equations will be given to you. You need to just put the values and find the equations. And once again, d double prime is denoting the slider acceleration. So the value we get, the absolute value of d prime would be the acceleration of pin joint A, linear acceleration of pin joint A, and the angle would be depending on angle would be 0 if the d prime's value is positive, and angle will be 180 if the d prime's value is. Alright, so the recap of crank slider. Usually the crank slider equation is less compared to the former linkage. So for step 2, for position analysis, you need to find theta 3 and d, which is slider position. And in step 1 you can find theta 3, and step 2 you can calculate slider position. Both equations will be given to you, so you don't need to remember them. Just to remember that for theta 3, the value you get from the equation is for cross configuration. When you add that angle with 180 degree or subtract that angle from 180 degree, that would be the angles for open configuration. For velocity analysis, once again you will be asked to find omega 3, which is angular velocity of coupler, and d prime, which is an acceleration of slider. Also you will be asked to find linear velocity of pin joint A. So for omega 3 and d prime, equations will be given to you for VA, linear velocity of pin joint A, and linear velocity of coupler AB. You need to derive the equation exactly like the forward linkage, and then you need to find the value in terms of magnitude and angle. Acceleration analysis, exactly like velocity analysis, that alpha 3 and d double prime equation will be given to you, and you need to derive linear acceleration for pin joint A and coupler AB, and then you need to find magnitude and angle. Some important tips is that just find E for crank slider is really important, and just remember that the angle is always measured from positive x-axis counterclockwise at the root of the vector. Angular velocity positiveness is counterclockwise, and if you get negative, that means it's clockwise. For crank slider, remember that theta 3 that you get from this equation is for cross configuration, and then when you add or subtract theta 3 from 180 degree or with 180 degree, you will get open configuration. And lastly, for linear velocities and acceleration, when you find the calculated angle in third or second quadrant, you need to add or subtract 180 degree with the calculated angle. Alright, so from these videos you understand how the crank slider length was considered. You were introduced the equations for position analysis, equations for velocity analysis. There are two types of equation. One is for angular velocities equation will be given to you. For linear one, you have to derive it. Acceleration equation is exactly the same. For angular acceleration equation will be given to you. For linear acceleration, you need to derive the equations. Okay, thanks for watching this video.